Okay, so you might remember me saying last time to hold off on doing problems 8 and 9 from page 3. It's because we finally now have more information on how to do that problem. So this is journal 9, our first slide for today, no bell work. So let's talk about when these inequalities here, this one is facing away the absolute value sign, right? It's facing away from the absolute value, whereas this one's facing towards the absolute value. So let's just label that real quick. Oh, my bad, misspelled. Okay, so another thing I want to mention here is that absolute values always give us positive numbers, right? Well, if it gives us positive numbers here, does this even make sense that a positive number is smaller than a negative number? No, that doesn't make any sense. Positive numbers are always bigger than negative numbers. So this statement can never be true. In other words, x is no solution because this side here is an absolute value. Whatever x that I put in here, whether it's -3, it will come out as a +3. If I were to put in 0, right, it would come out as a 0, but 0 is still bigger than a negative number. So no matter what x is, okay, this can never be true. So we call this no solution. And then on this side here, the inequality is facing towards, and like I said before, absolute values are positive values, or positive numbers. Right? So now this side can be true. Positive numbers are greater than negative values, but let's think about it here. What x values make this untrue? So let's just think about it. When x is a negative number, the absolute values make it a positive number, so it's still bigger than that. So negative numbers work here. If I plug in 0, 0 is still bigger than a negative value, so 0 is true. If I plug in a positive number like +10, it's still bigger than a negative number. So what I'm saying is, it doesn't matter what x is here. X can be whatever it wants and still make the statement true. In other words, this here is going to be all real numbers. It's just another way of saying that x can be whatever number it wants to be, and this statement will still be true. Okay? So now that we know these two pieces of information, we are now going to try to solve problem 8 and 9. So turn to page 3 of your homework packet, and we're going to solve that problem out together. So I'm going to shrink this down just a bit and grab number 8 here. So I believe number 8 is to find the intervals of absolute value of 3b plus 5 is less than -2. So on this side here, remember, the absolute value needs to be by itself first, and it is. And this side here, we said that absolute values will always be a positive number, right? And this side's negative. And the thing is, positive numbers are always bigger. So this statement here cannot be true. So that means that this here has no solution. Or if you just want to remember, anytime you have a negative number and it's facing away the absolute value, it's always no solution. Same thing, if anything is facing towards the absolute value, it's all real numbers. But I don't want you guys to remember things. I want you to understand that absolute values always give you positive numbers, okay? And to say that they are smaller than negative numbers is not true. And so that's why the answer here is no solution. Now let's take a look at number 9 here. Number 9 gives you a problem where it wants you to explain, solve it out and explain your steps. I'm not going to explain the steps out here, but we are going to solve the problem. So in this case, remember, absolute value is not by itself yet, so I need to get it by itself. So I have to move over this 2. So I'm going to subtract by 2. So I have 3n minus 2 is greater than 1 minus 2, which is -1. And so from here, my absolute value is by itself. And so let's take a look here. This is facing the absolute value. And remember, absolute value gives me positive numbers. And this here is a negative number. Well, in this case, positive numbers will always be bigger than negative numbers. So it doesn't matter what the value of n is. Whatever n decides to be and cause the absolute value to either be a negative or positive or 0, it will always be a negative. It will always be greater than a negative number. So in this case, this is going to be all real numbers. And also, just like, because this is facing towards the absolute value and there's a negative sign on the right-hand side, this follows what the answer would be. It'd be all real numbers. Okay, so now let's try some other problems here. Okay, so we're going to tune into our graphing skills here, and we're going to be graphing a linear function and an absolute value function. So a linear function, if I gave you a linear function, and if you guys can't remember, but this is your parent function for linear functions, which means it's the original function. It hasn't been shifted or anything like that. So if I were to ask you to graph this function here, I would first ask you, what is the slope and what is the y-intercept? And you would probably look at this and be like, well, the x is here and the number in front of x is 1. And so you probably say, well, my slope is going to be 1 over 1, right? Your rise over run. In this case, there's not another number out here, so your y-intercept had to have been 0. And then from there, if I were to ask you to graph this line, you would, draw your coordinate system, and you would start from the origin, right, to plot your intercept. So your y-intercept is at 0, so I plotted that. And then my slope says I have to go up 1 and over 1. So if I go up 1 and over 1, I'm right there. And then I'm going to plot and then connect the dots. And I have my line here. Actually, let me draw this line in pink. That way we can see the difference. So there's my line. And what I'm going to do here is now try to graph an absolute value function. I'm going to graph an absolute value function. So we're going to see what this one looks like. So if you don't know what a graph looks like, okay, what you do is you make a table. So your elementary teacher once said, you make a table. And so just to remind you is when you make a table, what you're doing is you're finding x and y values and you're finding coordinate points. So what I'm going to do is I'm going to choose some x values, okay, and then you're going to have to find the y values. So if I choose some x values here, like I'll choose some negative numbers, 0, and some positive numbers here. And what you're going to do is these x values will be plugged into the function, so that way you can get your y values. So if I plug in -2 into an absolute value function, that's like saying what is absolute value of 2? Well, that's just 2, right? Absolute values change the sign to positive. So this is 2. If I were to plug in -1, I would have +1. If I plug in 0, the absolute value of 0 is 0. If I plug in 1, I just get 1 back. If I plug in 2, I should just get 2 back. So looking at this here, now these numbers are correlated to each other and they are your coordinates. And I'm going to use them like they are coordinates. So I'm going to draw me a number line, not a number line, a graph. I'll make some plots here. Maybe I'll make this like 1, 2, make some dash marks. This is y, this is x. And so looking at this here, if I were to plot this, this says -2, 2. So -2 up 2. -1, 1. So -1 up 1. My third point is 0, 0. So in that case, that's the origin. And then 1, 1 is here. And then 2, 2 is here. And then once you have all the points plotted, you try to connect the dots. And when you connect the dots, you make a, oops, sorry, that was not very good connecting. You make a V. right? It looks kind of like a V. And so in this case here, our V is what it seems to be the shape for an absolute value function. And so first let me talk about why this is the case. So let me just say that these two functions have some relationship with each other. By the way, this is the parent function for absolute value functions. It just means that this is the original function for absolute functions, okay? It hasn't been shifted yet. Okay, so looking at this part here, I want to mention that they are both x to the first power, right? And so you'll notice some similarities. Like this side here is very similar to this side here. Like they're both pointing up. I also want to mention that this is 1, 1. So notice how like when you plug in 1 into this equation, y is also 1. When you plugged in 1 into this equation, you also got y to be 1. That point is the same point. If I were to plug in 2 into this equation, y would be 2. So if I went here, it'd probably be at 2, just like this equation. So I'm saying that this side is the same side as this part of the graph. The only difference is when you get to this part of the graph, right? These two parts here, the other left-hand half, are different. Well, if you think about it, it's because of the negative x values, right? So when you plug in something like -2 into this function, y is going to be equal to -2. And that's why you're down in this third quadrant, is because you had to go to -2 and then go down to -2. Whereas when you plug in a negative into an absolute value, it becomes a positive. And so you want to be in this upper region here to +2. So what happened here was it's like they cut off this part and they stuck it up in the third quadrant, connecting it with the other side. And so that's how I've always imagined linear functions when they're transformed to absolute value functions, is like they cut off a piece, they sticked it a different rotation or orientation. Okay, another thing I want to mention is that this dot right here, the middle of this V, is called the vertex. And the vertex here is 0, 0, right? It's the coordinate 0, 0. And so that pointy corner or that vertex there, when we are looking at it, we also have to name whether it's a min or a max. And to do that, if it's a minimum, that means it is the lowest point on the graph. So taking a look here, this point is the lowest point on this graph. So this would be a minimum, okay? If it was the highest point on this graph, then this would be the maximum. So let me give you another example. So minimum is something like a V, and then the bottom here would be your minimum. Whereas if you had a V that was like upside down like this here, your vertex, would be called your maximum. So that's the difference between a minimum and a maximum on an absolute value function. All right, so now let's take a look at what happens when you graph an absolute value functions and you add some shifting to it. Okay, so we're going to talk about graphing absolute value functions. And what we have to understand is all the different types of shifts that could happen. So I'm going to just draw me a quick coordinate system with each one of these, and then we'll take a look at each one's shift. So I just want to mention here that these two look almost the same. They both have 2's inside the absolute value sign, but this one's a positive and this one's a negative. So these two actually help us figure out the horizontal shift. So whether you're going left or right. So whenever it's a positive sign on the inside, you actually shift left. And in this case, you shift left 2 units. So 2 units. And so what that will look like, do you remember that origin starting at the vertex starting at the origin right here? Well, now that vertex is going to be shifted 2 units to the left. So I'm going to be going this way instead. So I'm going to make some dashed lines here, plot my vertex, and then draw my V, because that's the shape for absolute values. So at -2 now, or -2, 0, that would be my vertex. So when it's on the inside and it's a positive number, it shifts left. So this one here, if it's a negative, on the inside, it's going to shift right 2 units. And so we would go this way to +2 and then draw our vertex, make our V. And I'm doing a very rough sketch because I just want you to notice the shifting. And then this one here, you have the absolute value, and then you have a +2 on the outside. So if you have a +2 on the outside or -2 on the outside, this is what we call our vertical shift. So if you have a +2, you're going to be shifting up 2 units. So what that's going to look like is, remember, we start at the origin. And if we're going to be shifting up 2, then that means we need to go this way, up on that y-axis, and then draw our V. Okay? And then the other one must be shifting down 2 units. So down here, and then we're going to make our V. Okay? And so we always start at the origin, and then once we figure out our shift, we're going to shift in that direction. So like this one here is really weird. So whenever you have a negative sign in front of the X, what that happens is that it inverts it, or it puts the V upside down. So our vertex is still going to be at the origin because there's no shifts here, or at least horizontal or vertical. But what will happen is that this V is now going to be upside down because it's negative on the outside. So it wants to be pointing in the negative direction. So this is going to be, I'll just write flips upside down when it's a negative. And that's all 5 types. Okay, so we're going to do an example problem of this so that way you guys get a feel of how you can graph absolute value functions. Okay, so when we're graphing absolute value functions, so first thing I like to do is figure out my shifts. That's really important. So like this one's number 1 on homework. Oh, let me write that on here. So this is the homework packet. So packet 2, and this is page, I think it's 4, page 4, number 1, as you can see. So with this problem here, if you take a look at this equation, you have a +3 on the outside of the absolute value. So that tells me that it's going to be a vertical shift, and it's going to be moving up 3. So remember, we start at the origin for our vertex, but in this case, we shift up for 3. So that's going to be 1, 2, 3 right there. I'm going to plot my point. And so that vertex right there is at 0, 3, right? So I have my coordinate for my vertex. By the way, when it's asking for the vertex, it just wants the coordinate point. And then from there, I need to draw my absolute value function, okay? To do that, I'm going to need actually 3 points. So maybe I need to write that there. So absolute, put this as a side note, values need 3 points when you're drawing them. So what that will look like here is I need the slope to do that. So take a look at this here. This x is right here, right? The number in front of the x, there's not a number here, so we always assume it's 1. So I'm going to use the slope to find the other points. Just like if I had a linear line to find, I would have the y-intercept, but I would need another point, so I would use a slope, right? I'm going to use my slope here, which would be 1 over 1. And so from the vertex, I am going to go up 1 over 1, plot, and then draw and connect the lines. But here's the thing, that's only one side of the V, right? So you need the other side of the V, which is probably going to go that way, because the V is a reflection of itself. It's symmetrical. So instead of going up and over to the right, you're going to go up 1, but over to the left. So you go in the same like vertical direction, but opposite horizontal direction. And then we would draw our other side here. And so based off of this here, our vertex, which is down below this graph, right, the lowest point, this is going to be a minimum vertex. And that's it. So now try out problems from page 4 and see if you can do some more problems. If you want to see more problems done, look for journal 10. And there are a ton of homework problems that I do in that journal. And if you have a hard time understanding that, just watch the video. All right, guys, that's all for today. Bye.